The cubic function. A cubic function is, so we're in the topic called nonlinear functions. I was saying this topic is called nonlinear functions. So a nonlinear function, we've looked at one type already, which is the quadratic function or the parabola. The next type of nonlinear function that we're looking at is a cubic function. Now, it's called a cubic function because the highest power of the variable is 3. You know, like when you do something cubed, you do it to the power of 3. So this is a cubic function. And the graph of a cubic function is called a cubic curve. And we're going to be investigating cubic curves. So if we look at all these curves here, y equals x cubed, that's a cubic. Negative x cubed plus 1, that's a cubic. A half x cubed, d is a half x cubed. C is 4 minus v cubed. The highest power of the independent variable is 3. So they're all cubic curves. Yeah. So now the shape of a cubic curve. So here is a table of values for y equals x cubed. Now we're going to be doing our own graphs over the page. But if we've got y equals x cubed, let's start from 0. When x is 0, y is 0. When x is 1, 1 cubed is 1. When x is 2, 2 cubed is 8. So this is a table of values giving us x, y values. When x is 3, 3 cubed is 27. Now, doing the negative values, negative 1 cubed, a negative times a negative times a negative is a negative. But you could just put it in your calculator. You get negative 1. Negative 2 cubed is negative 8. Notice, see how you got 8, negative 8, right? Negative 3 cubed is negative 27. So you would graph it. We're going to be doing graphing over the page, all right? Now, when we do graph it, it will look like this. This is a cubic. Looks like that, all right? And so we can have cubics that look this way. They look like this. It's your normal cubic like that. With this type, A will be positive, but if your cubic goes back this way, your A will be negative, but we're investigating this on Desmos, all right?
So is that like the same thing with...
A really good point made there. Remember that positive lines have gradient like that. So your positive cubic looks like this. Negative lines have gradient like that. So that's your negative cubic like that. And what we're going to be doing as well is looking at the steepness of these graphs. So we're going to investigate and then we'll come back to this, all right? And now I could use Desmos to do this, all right? I actually did graph these in Desmos. So I've got my y-axis and I've got my x-axis. Instead of graphing them in Desmos, from what you know about straight line graphs and which ones are steeper, and quadratic functions and parabolas, which ones are steeper, look at all these graphs, y equals x cubed, 2x cubed, 5x cubed, and a half x cubed. Which one do you think the green one is? All right, let's see. If we think that the green one is 5x cubed because it's the steepest, how could we tell? So let's look at y equals 5x cubed for a minute. Now, I'm going to just do a little table of values for y equals 5x cubed. And I'm just going to do a couple of points, negative 1, 0, and 1. Okay? So when x is negative 1, for the curve y equals 5x cubed, actually let's do 0. When x is 0, what's y? Girls, I'm doing a table of values. 0 cubed is 0? No. 0 cubed is 0 times 5 is 0. When x is 1, what's 1 cubed?
1.
1 cubed is 1 times 5 is 5. And what's, for negative 1, what's negative 1 cubed? Negative 1 times 5 is negative 5.
We are correct.
So I want to see which curve has the points 0, 0. Well, they all do. The point 1, 5. So when x is 1, y is 5. That's up there. Can you see that? And also looking down here, when x is negative 1, y is negative 5. That's that point there. So that's how we can tell. Yep. So let's label our first graph y equals 5x cubed. All right, let's look at, I don't want to do them all. Let's look at y equals a half x cubed.
That's the yellow one.
Yeah. Yeah, it should be the yellow one. I'm going to just do, I'm not going to do the values of 1 and negative 1. I'm going to do the values this time of negative 2, 0, and 2 because we're halving. Half of 2 will come out nice, all right? Or Half of 1's just going to be a half, and you can't see it on the graph properly. So let's look at y equals a half x cubed. Let's start with x is 0. 0 cubed is 0 times a half is 0. Let's do x is positive 2. What's 2 cubed? 2 cubed. 8. Half of 8? 4. And what's negative 2 cubed? No, negative 2 times negative 2 times negative 2. Oh, yeah, negative 8 times a half is negative 4. Got it.
It's the yellow one.
Good. So let's have a look. We've got the points 0, 0, 2, 4. You've got to look at the scale, girls. And I don't have each point drawn here. Negative 1, negative 2,
It's red, blue, green.
negative 4, negative 5. And then I've got negative 2, negative 4. Are we good with that? So the yellow curve is y equals a half x cubed. Now, just looking at this pattern, what do you think the red one is?
The x3.
Yeah, the red one is y equals x cubed, and the blue one, y equals 2x cubed. Are we good? So, girls, it's very similar to parabolas. The steepest one has the biggest coefficient in front of the x cubed. Just like straight line graphs, the bigger number in front of the x is steeper. The smallest number in front of the x is the wider graph. Okay? Are we good with that? So we're now going to investigate. So this is the general type of this one is y equals ax cubed, where a is positive. That a value is positive in all of these. Actually, with the first one, what does the a equal for the first one? What's in front of that x cubed? Well, this is 2x cubed, 5x cubed, a half x cubed. Is this 0x cubed or 1x cubed? The first one.
The one about this one.
It's 1x cubed, just in case. So see, you've got 5, 2, y equals x cubed is 1x cubed and a half.
Miss, I don't get what that first part says. I don't understand what it works.
This is graphs of the form y equals a, where a is a constant.
So
A is just a number,
right.
a whole number, or a fraction. A is a number where a is greater than 0, meaning that a is positive.
Right.
So a here is 1, a there is 2, do you see? A is 5, a is a half.
So then in the next one.
Okay, so we're now going to investigate. Yep.
Right.
And so are we good for that? All right. It means it's curved this way. Look at the 3. We've got y equals negative x cubed, negative 3x cubed, negative a half x cubed. Which one do you think the green one is? Which one's the steepest?
Negative it. No, negative half.
All right. Okay. Actually, with this one, yes, I know what you're saying. Even though negative 3 is a smaller number,
I said
the negative
X.
just means it's turned this way. No, the negative 3 one should be the steepest.
Yes.
The negative means it goes this way. 3 means it's steep. So we're thinking this one is negative 3x cubed, but let's substitute some values to find out. So I'm going to substitute negative 1, and I'm hoping to get 3. Or I can substitute 1, and I'm hoping to get negative 3. Can you see? So let's do a table of values for this one. And we'll see. Y equals negative 3x cubed. When x is 0, y is 0. When x is 1, 1 cubed is 1 times negative 3 is negative 3. So 1, negative 3. It's the green one. And negative 1 cubed is negative 1 times negative 3 is positive 3. Negative 1, 3. So the green graph, see, this is steeper. Look, just pretend you're walking up the hill. This is the steepest hill, then that one, then this. So y equals negative 3x cubed is the green one. Which one do you think negative a half x cubed is? It's the flattest. It's the red one. Y equals negative a half x cubed. And the middle one should be y equals, negative x cubed. There's a negative there. Now, let's just check with the negative half one. And I'm going to do negative 2, 0, and 2. Otherwise, I'll get halves, and I don't want to get halves in my answer. So, again, when x is 0, y is 0. When x is 2, 2 cubed is 8. Negative a half times 8 is negative 4. And here, negative 2 cubed is negative 8. Negative 8 times negative a half is positive 4. So looking at those values, negative 2, positive 4, and 2, negative 4. Are we okay? So this, I've only graphed negative 3x cubed and negative half x cubed. I've graphed the others, but I'm doing tables of values only for those two. All right? So again, negative goes this way. Green is the steepest, negative 3, then negative 1, then negative a half. Right? Negative tells you which way it goes, and the number tells you how steep it is. So don't think, I know negative 3 is smaller than negative a half, but we don't look at it like that. We say negative goes this way, and the 3 is steeper.
So it's just irrespective of whatever sign is.
If this is the negative 3x cubed, if I was to draw 3x cubed, it would be exactly the same steepness, but just this way. The positive 3x cubed one would be the same steepness as the negative 3x cubed one, but just facing the other way. All right? So we've got y equals ax cubed, our original graph, plus c, where the a is positive. So yes, it goes this way. I've got 3 graphs there. One of them is just y equals x cubed. No shift up or down. Which one do you think that is? Y equals x cubed. Yeah, it's the red one. But let's just look at a point. Let's say when x is 1, what's y? Table of values for this one. When x is 1, what's y? Yeah, it is. Look, the red one. 1, 1. That's 1, 2. That's enough, as long as I've got 1 point. And negative 1 will be negative 1. Negative 1, negative 1. So the red one is y equals x cubed. So basically, I take y equals x cubed and shift the whole graph, push it up 3 units. Is that the green or the blue one? The blue. The blue one is y equals x cubed plus 3. Does this make sense? The red one is y equals x cubed.
So then in those ones.
Yeah, it's just y equals x
then in
cubed
those ones where it's got
pushed
the
up.
YX part, just the number.
It's
Then
whatever that
after
graph
it-
is, and then you go plus 3 to each of these
no,
values.
I'm saying like if you're going to try and figure out
Oh.
which one would be steeper, is it just the number that comes after the plus or the minus? Whichever one's
Okay,
higher?
these actually are all the same steepness. I know they don't look the same steepness, but they are. I could move that red graph and shift it on top. It will move on top of it. They're all actually the same steepness.
So it's just the number that's in front of the x will indicate steepness.
Yes, the number in front of the x indicates steepness, and the plus 3 or the minus 2 means the whole graph was moved up 3 or down 2. So that red graph, if I pushed it up, it would sit exactly on top of the blue one, and the red one, if I push it down, should sit exactly on top of the green one. So let's just look at a table of values, for example, for y equals x cubed plus 3. Let's do when x is 0. 0 cubed is 0, plus 3 is 3.
So then
It
it's
passes through the
4.
point 0.3. See, you know what you can do? You can just add 3 onto the values in the table above, because we know that 1 cubed is 1, plus 3 is 4.
And then you can just
This
minus
is
2
1,
from the
4.
original.
And this one, negative 1 cubed is negative 1 plus 3 is positive 2. So this y equals x cubed plus 3 is the blue one. The x cubed is the red. And the x cubed minus 2 is the green. Are we good? Does this make sense? We just take the y equals x cubed and we shift it up 3, slide it up. Take the y equals x cubed graph and shift it down 2, slide it down. Okay? Let's sketch y equals x cubed plus 5 together. Want a little table of values. We'll do this one I'm doing it in pink. I'm just going to do the values of negative 1, 0, and positive 1 for y equals x cubed plus 5. So let's start with 0.
So it starts at 5.
So when x is 0, yes,
So then
0
5
cubed is 0, plus 5 is 5. When x is 1, 1 cubed is 1, plus 5 is 6. So let's do those 2 points. 0 across, 5 up. 1 across, 6 up. So it's looking like this, so it'll just curve. And negative 1 cubed is negative 1 plus 5 is positive 4. Negative 1 up 4. Look, I could do 2. 2 is going to be 13. Oh, okay. I'm not really going to fit it on my graph, so. No, it's, yeah. point actually. I'm going to put the -2 over here because -2 cubed is -8 plus 5 is -3. So I can actually put that one in. -2, -3 is down there. So it's got to be a smooth curve. It looks like that.
It would be smooth if you just went.
Yeah. So girls, I decided that I do the -1. I know that's a -1. I should have put it first, but I can read it here. -2. I can see the value anyway. Look, -2, -3 after I've drawn it anyway. Okay, so are we good with that? We're going to do the same thing now. So this is the positive cubic shifted up and down. We're also going to do the negative cubic. So there are 2 things you can do, or 3 things. You can have the positive graph, the negative graph, 4 ways. Positive graph, negative graph, shift it up or down, and make it steeper or wider. So 3, 4, 6, whatever. Lots of different things you can do. All right, let's look at the next type of graph. So this again is the y equals ax cubed plus c graph where a is negative, so it's the negative gradient, but just shifted up or down. Let's look at, from what we know so far, let's take an educated guess, and tell me which graph is which. Negative x cubed, which one? Negative x cubed, which graph? The red. It passes through 0, 0.
Isn't that the same thing?
Negative x cubed plus 2. Is the negative x cubed graph shifted up 2 is the blue curve.
Yes, it's the same thing.
And the negative x cubed graph shifted down 3 is the, which colour?
The green one.
It's the green one. So just by doing this so many times, you can sort of see y equals negative x cubed. If you have to, just look at the red one. You could do a quick table of values or just a quick check of any value. When x is 1 for the red one, 1 cubed is -1. So we've got 1, -1 for the red one. Or for the red one, if you did when x is -1, -1 cubed is -1, and negative that is +1. So if you did do a table of values for the red one, you would get those points. 1, -1, -1, 1, and 0, 0. And we can see that the red one is y equals negative x cubed. Now +2, the negative x cubed is already worked out. You just add 2 onto each of those values. All right, and that's the shifted up 2, and the green one is the shifted down 3. Now, if we were to sketch y equals negative x cubed plus 5. So I'm going to do x, y. I'm going to do -1, 0. Actually, I'm going to do, 0, 1, and +2 this time. All right, let's go. We know the negative x cubed values. They're worked out in the table above. So -1 cubed is -1 times negative is +1 plus 5 is 6. -1, 6. 0 cubed, or -0 cubed is 0 plus 5 is 5. 1 cubed, or 1 cubed is 1, so -1 plus 5 is 4. And 2 cubed is 8, so -8 plus 5 is -3. So 2, -3. I'll just see what -2 gives me. It gives me 13, but that doesn't fit on my graph. So we just join the curves, join the points with a smooth curve. And this will go up. So the pink one is y equals negative x cubed plus 5. I know it should be a bit flatter like the others. Okay, same shape as the others, just shifted upwards. Plus 5. It's really important to put the arrows on the ends because these lines continue. They don't just start there and stop there. So you must put arrows on the ends. All right? Do this -1 on your calculator. You would go minus. You'd put the negative. You'd put the negative bracket -1 close brackets 3. This has to be a negative bracket, -1 is what's being cubed, plus 5. That's what you put on your calculator for the -1. Got it? But for the 2 you've got to be careful on your calc for x is 2. So on your calc for x is -1, you put your negative, and then your x is actually -1, so you must put it in brackets. But for the x is 2 on your calculator, the way you do it is as follows. You put the negative there, that's a -2 cubed, and you've got to, you could put the 2 in brackets, but it doesn't need to be. But what you've got to make sure, wait, is that that -2 is not in brackets. It cannot appear in brackets. I don't want to see -2 in brackets cubed. It has to look like that. Because it's not the negative that gets cubed. It's only the x that gets cubed, not the negative. This happened to be a negative x value. So if you want, you can go -2 in brackets and then cube it. But the negative is not to be cubed out the front. Plus 5. That should give you -3. And this one should give you +6. Now, if you're not getting that right, you're doing something wrong. Like this, they're both the negatives. There's only 2 of them. You should do those first because there's only 2. Here they are. A and E are the negative ones. From what we've done, which one's steeper? -x cubed or -half x cubed? No. That's -1x cubed. -2x cubed would be steeper again. -3x cubed. -1/2 x cubed is flatter. It's got a smaller sort of what you call gradient, I suppose. It's not really gradient, but it's the coefficient. Go back and look at your things. The half one was the widest. So what's A? Yeah, that's -1/2 x cubed. And this one's steeper. -x cubed. All right, so A and E are done. All right, that was E. No, that was A. That was E. But I'd write them.
Right, so then D is E.
All right, these are all positive, but girls, let's look at the, look at the positive ones. -1, ¼ x cubed, 4x cubed, +1. There were 2 that were shifted up and down, and 2 that aren't shifted up and down. Let's look at the ones that aren't shifted. And which one's steeper?
So D is E and F is C.
So this one here, is this steep? That's very steep. Which one's that?
4x.
That's got to be the 4x cubed. That's steep. Okay? The ¼ x cubed, which one would that be? It's not shifted up or down.
This is a really big one. This is one.
I think there's a mistake.
Yeah, Miss, I think.
Yeah, I think this one here, they haven't drawn it properly. It's a little bit off. This should pass through there.
Yeah.
It's a bit of a mistake on the diagram. So this one is a ¼ x cubed, girls. But they've made a mistake. It's slightly moved. Must have been in, you know, if you're, you know, Control Shift, that should actually go through the origin. It's a bit of a error in the drawing. That's a ¼ x cubed. All right. This one here, has it been shifted up or down?
Absolutely.
So that's the x cubed +1. See that? That's shifted up 1. And this one's definitely shifted down. So this must be x cubed -1 because it was shifted down. If you're just picking out of the ones that they've given you. Okay? I know that one was a bit off. The drawing was a bit off. Okay? A light material with a cubic centimetre. That's a little centimetre cube. Remember primary school? The little brownish tan coloured centimetre cube. Weighing only 0.25 grams. The mass M of a cube of cork of length S centimetres is this. M equals 1/4 S cubed. 1/4 S cubed. It's a cubic. It's going to look like this. But the thing here is they don't give us the negative values. You only see that full shape, girls, when you do the negative values as well. Look, I'll show you. See here, you've substituted in negative values and positive values. Like, for example, here, you're only going to see one side of the cubic. No, they're not substituting negative x values. So it's not going to look like a cubic if I graphed it, all right? Copy and complete the table. So can you start substituting, please? So it's 1/4 times 5 cubed, for example. So that's 125 on 4, which is 31.25. The next one, 10 cubed is 1,000. 1/4 of that is 250. 30 cubed, 900. 9,000, is it? Sorry, no. 30 times 30 is 9. 30 cubed is huge. It's 27,000 or something. Divided by 4, which is 6,7. These getting very big. 50 cubed, 125,000 divided by 4. Is that 62? Yeah. So they're getting really big, all right? And 60 cubed, etc. There's not much room for those numbers. Anyway, you can finish them off. Have you done them, the last two? 8630? Oh. Whatever it is. Okay, now, calculate the mass in kilograms. Now look at all this. The mass M is in grams, so we'll have to convert to kilograms. So calculate the mass in kilograms of a cork of cube length 45. So we're going to use our formula. M equals 1/4 S cubed, which is 1/4 times 45 cubed. What do you get, girls? Anyone?
91. Wait, 91.
Tell me what you get. What do you get when you substitute that in? What do you get? What do you get in grams? 0.25 grams. And then you read the question carefully and it says calculate the mass in kilograms. What do you get? The last one? 22.7. Okay, good. Yes. Whatever. All right, keep going. See, you need to be really, really careful because the formula does not use kilograms. It uses grams. So in part C, they've got convert 93.312 kilograms to grams. Oh, they're helping you. What is it? 93.312 times 1,000, which is 93.312 grams, and that helps you with part D. So, you know, but sometimes they're not going to guide you like that. This is very guided. So you're lucky they asked you about part C, because when you use the formula M equals 1/4 S cubed, that M has to be in grams. Okay? So they want the side length of a cube that has mass 93.312 kilos. You must put in the mass with grams. So now what are we going to do? Off you go. 93.312 times 4, because this is really S cubed. That really is, if you had to write that as a single fraction, isn't the S cubed on the numerator? It's really 1 S cubed on the numerator and 4 on the denominator. We okay with that? So now we do 93.312 times 4 equals S cubed. Anyone got an answer for 93,312 times 4? Isn't that 300 and...
173,002,048.
Equals S cubed. All right, what is the inverse operation of cubing? What's the inverse operation of squaring? If I give you x squared is 25, x is the square root of 25. If I give you x cubed is 27, x is the cubed root of 27. So S is the opposite inverse operation of cube is cube root. So S is the cube root of 373,248. And that will give you the answer in centimetres. So girls, I've just reminded you, if you've got something squared and you want the x, you square root. If you have something cubed and you want to find the x, you cube root. All right? Like here, inverse operation of divide by 4 was times by 4. Inverse operation of cubing is cube root. This is that little 3 at the very top up there. What do we get? 72 point, is that it exactly? 72 centimeters. Okay, good. So that's the length of a cork cube that has mass 93.312. Now we have to calculate the mass of a cubic meter of cork in kilograms. Girls, you got to get the units right. A cubic meter. Ladies, what is a cubic meter? It is a piece of cork. It's obviously huge. That's 1 meter times 1 meter times 1 meter. You don't go and put that all in. What do you substitute into the formula? Look back at the formula. Let's read the question. Cork is a light material with a cubic centimeter weighing that. The mass m of a cube of cork of length s centimeters. What's the length of my cube of cork? 1 meter, which is how many centimeters? So you substitute 100 centimeters into your formula. Girls, it's really important that you read the units of the question. Now, when you use this formula, it's going to give you the mass in grams. All right, so that's the formula where S is the side length in centimeters and M is the mass in grams. So I know they're asking you kilograms, but you must substitute into the formula with the units of the formula. It'll spit out the answer in the units of the formula. Then you're going to have to convert again. So you can only put centimeters into this formula if you're substituting S. And if you're substituting M, you can only put grams into the formula, not kilograms. And the formula spits out grams, not kilograms, right? So it's a quarter times, S is 100 centimeters, so 100 cubed, which is 1,000,000 divided by 4, 250,000 grams. Because the formula gives you the mass in grams. All right, I need it in kilograms. So girls, a cubic meter, that is a meter long, a meter wide, a meter high. Pretty big. It's like a cage, a big cage. All right. Now, what's that in kilograms?
2,500.
Yeah, we divide by, no, you divide by 1,000, which is 250 kilograms. So, and the last question is, can a person lift a cubic meter of cork? Do you think you could lift 250 kilos? No. A person, well, not us anyway, cannot lift 250 kilos. Just think what you weigh. You're not going to lift 4 times your weight or whatever, 3.5, whatever it might be, 3 times your weight, whatever it is, unless you're a weightlifter. And even then, I don't think they can lift 250 kilos.
They can.
They can? Well, weightlifters can, not your everyday person, all right? It's the weight of quarter of a car, of a decent sized car.